So now this video discusses about the parallel vectors, and this is specifically for secondary school students in mathematics. So what are the parallel vectors? Let's say we have this is a vector A, and let's say we have another vector. Let's say this is the vector B. Now these two vectors are said to be parallel because they have the similar orientation, and these vectors, they'll never meet, hence they're said to be the parallel vectors. So like the same way we discussed about the parallel lines, it is the same way the vectors has to be expressed as well. The parallel vectors, these vectors, they never meet. So a vector A as well as the vector B, they're said to be the parallel vectors. Now, while let's say we have this is a vector A, and let's say we have another vector, let's say a vector B. So now in this case, these two vectors are not parallel because if we think of extending this vector, it will intersect with this vector, hence those vectors are no longer parallel. Now the vectors can be parallel but in opposite directions, that is okay. And the vectors can also be parallel while the one is having the large magnitude than the other. For instance, let's say this is a vector A, and it is parallel with vector B. Now these two vectors are actually parallel, only that the vector A is longer than the vector B, but the fact that they never meet, those vectors are said to be the parallel vectors. So now, how can you be able to actually show whether the given vectors are parallel or not? Now, how can you be able to show whether the given vectors are parallel or not? Let's say we have the vector A, and that is given as 18, and that should be down 24. Let's say that is the case, and we have another vector B that is given as 24 and down 32. Now that should be 24 down 32 is. So now, how should we show whether these two vectors are actually parallel vectors or not? Now, the two vectors are said to be parallel if they obey this principle. You know, the one vector has to be equal to the scalar product of the other vector. If this principle is to be obeyed, then the vectors are said to be parallel. Now, one vector has to be equal to the scalar product of the other vector. So in other words, the vector A has to be equal to the scalar, that is a k, times the vector B, that is the scalar product, where k it's a scalar value, that is the constant. Of course, it can be k or whichever the constant of our interest, but preferably we are making use of actually k as a constant. In this case, we have a vector A is equal to k, actually a vector B. And what is the value of the vector A? We have it as 18 down 24, and which is equal to k times, that is 24 down 32, as you can see there. Then we'll have to distribute the k, that will be given as 18 down 24. Now that should be this 18 down 24, and that is which is equal to 24k and down 32k. So in that case, mind you, this is the x actually component of the vector, and this is also the x component. Y component, this is also the y component. Then we'll have to equate them. So in that case, we'll have it as 18 is equal to 24k. And what is the value of k in this way? We'll have it as 18 over 24. Should be 18 over 24. And now what will be that? If we think of simplifying that one, so in this case we'll have it as, that is k is equal to, that is 9 over 12. Of course we can still more simplifying further. Let's think of using 6. So 6 into 18 is given as 3, and divide by 4. That is the value of k. And also let's go for the actually a y component of the vectors. So have 24 is equal to 32k. Now for this case, what is the value of k? Now the value of k will be given as a k is equal to 24 over 32. So now how should we have it? Let's think of simplifying further. We'll have it as 3 over, should be 4, if we actually divide everything by 8. We'll have 8 into 24 is given as 3, and 32 is given as 4. Now since the values of k in both components, that is along x as well as y, and for the vectors is the same as, actually is the same, it means the two vectors are said to be actually a parallel. That's how we should have to get it up. So which means what it means is that the vector A is said to be a 3/4 actually vector B. So this is the value of the scalar product. So in this case the vectors are said to be parallel because the values of k in both components x as well as y are the same. If it could be that the value of k are different, means the vectors couldn't be parallel. That is, let's say we have also this case. Let's say we have the vector c, and which is given as 0 down 3. And let's say we have the vector d, which is given as 3 down 0. Now let's see if these two vectors are actually parallel vectors. Now principle remains the same. The vector c has to be equal to the scalar product of the vector d. Then the vector c is given as 0 down 3. That will be equal to k times 3 down 0. Now this is the same as, now we have 0 down 3, and which is equal to, of which you have it as, that is 3k down 0. So now for this case, as it stands here, these two vectors are no longer parallel vectors. And these vectors are no longer parallel vectors because we have 0 is equal to 3k, and of which k will be given as, should be 0. And how about this side? This side we'll have it as 3 is equal to 0 is something that we will not be able to express it about. So those two vectors are not parallel. Now let's say we have also this kind of a case. Let's say we have, a vector should be m, that is given as 10 down 5, and we have the vector n that is given as, let's say 2 down 1. Now we should have to show whether these two vectors are parallel or not. So in this case we have m is equal to the scalar product of the vector n, that is 10 down 5, which is equal to k times 2 down 1. That is the same as 10 down 5. That will be given as 2k and down k. So in this case we'll have it as 10 is equal to 2k, of which k will be given as 5. And also have 5 is equal to k. So in this case, since the values of k are the same in both components, then the vectors are said to be parallel vectors. So keep that in mind. let's say we have, in this case, let's say given that the vectors, let's say m, which is 2 down -3, and the vector n, which is 8 down, let's say y, are the parallel vectors. We should have to calculate the value of y, given that those two vectors are parallel. We should have to calculate the value of y if these two vectors are said to be parallel. Now, how should we have it all? So in this case, principle remains the same. We'll have vector m, which is equal to the scalar product of the vector n. So that would be given as 2 down -3, and which is equal to now k times 8, or actually down y, which is the same as 2 down -3, and which is equal to 8k, and then down ky. So in this case, we'll have 2 is equal to 8k, and of which k will be given as 2 over 8, which is the same as 1 over 4. Then we'll have -3 is equal to k actually y. We'll substitute for k here, this of y, it will be k. So try to have that way in that case. You should have to convert that on in that way. Let's say we have the vectors, let's say vector s, which is being given as q plus 1 down 4, and we have the vector p, which is given as, let's say, 1 down 5. Now find the value of q given that the two vectors are actually parallel vectors. So now principle remains the same. We'll have s vector, which is equal to the scalar product of the vector actually p. So have q plus 1 over, let's say, 4, and which is equal to k times 1 down 5. So that is given as q plus 1 down 4 in that way, which is equal to k down 5k. So that is, then we'll have it as q plus 1, which is equal to k. That is, and we'll have this one as equation 1 because we have two unknown values. Then we'll have 4 is equal to 5k. Now solve for k, substitute here, solve for q. So keep that in mind. Now try to have the following problems in your own time. We should have to show whether the vectors are parallel vectors or not. Let's say we have the vector a, that is -8 down 12, and then we have the vector p, that is 2 down -3, and you should have to show whether these two vectors are parallel vectors or not. And also try to have this one as well. Let's say we have a vector a, that is -5 down 6, and then we have the vector b, that is being given as -12 down -10. And show whether those two vectors are parallel vectors or not. And also let's try to have this one as well. And also let's say we have these two vectors that are said to be parallel. Let's say we have the vector o, that is given as m plus, let's say, 6 down 2, then we have the vector p, that is given as, let's say, 2 down 4. Now given that these two vectors are parallel vectors, determine the value of actually m. So that's how the parallel vectors can be evaluated. Thank you.